see, when I increase I mu, flux is increasing, but when I am decreasing, this is I mu I am increasing, when I am decreasing I mu, B max not following the same curve. Here first I mu I increases, B also increases in the same curve. Now when I decrease I mu, B max is not following the same curve. It is decreasing somewhat slower than I mu. That is, what does it means? That suppose during positive cycle, this is the orientation of after completing of half cycle, this is the orientation of magnetic domain. Suppose during this positive cycle, this is the domain. Now when you reduce the current to 0 and when it is going in negative cycle, consider at point A, that is 0 crossing. Now consider the case of 0 crossing. What you want to consider? Consider the case of 0 crossing. Now all domains will change its direction. All domains will change its direction to random direction at that zero crossing. All will change to some random direction like original case, but two of this magnetic domain remain as a previous case. So you need an extra forces to make reverse in next cycle. When you apply negative cycle, all the domains will be in opposite direction except one or two which try to refuse due to inertia. Now you required an additional forces to reverse this magnetic domain, that is called coercive force. We will discuss here. So see here, now when you increase I mu, the flux increases, but when you decreasing, first you increase I mu follow, when you increase I mu, B follow in that direction, but when you decrease I mu, B max is not decreasing in the same manner, it is decreasing somewhat less. Observe here, it is decreasing somewhat less. When I mu reduced to 0, B max is not 0 because some of this domain are remain in that condition, whereas another all domains are in random direction. See, when the domains are in random direction, there if you make horizontal and vertical component, all this going to cancel each other, but due to these two domains, some magnetic field still exists in the core. When you remove supply, some of this domain remains in the previous direction, so that net flux is not 0. So current is 0. See here, current is 0 but flux is not 0. Hope you have understand why flux is not 0. Now as I have told you, to reverse this domain during negative cycle, you need an additional power. This is first increases, then they decreases. In the negative half cycle, see this is during negative half cycle. To reduce, see, this is the value of B, and this is the value of I mu is 0. Now you require some current to reduce the B max to 0. You required an additional current to reduce the I mu to 0. So you required this amount of current, some X current, so that I mu reduces to 0. This is all the losses. So the current which are you giving from 0 to X are going in form of losses. So this is called hysteresis losses. Means to reverse the domain, due to inertia, some domains tends to be in previous condition only. So additional current, additional power which you give is called hysteresis losses. Hope you have understand. This 0 to X means this is 0, this is X. So this value of flux exists when current is 0 is called residual flux. Actually this is the flux is useful in case of DC machines, self-excitation DC machines, whereas it is causing a loss here in transformer. Now 0 to X is called residual flux and 0 to Y is called residual force or coercive force required to bring the flux to 0. Now what see the here, see the definition. The property of magnetic material tend to remain some flux even though magnetizing force is 0 is called retentivity. Yes, it is true. Now move ahead. What is coercive force? The force minus Hc or plus Hc required to bring the residual flux to 0. Residual flux to 0 is known as coercive force, and the property of material is called coercivity. Coercivity. So see here, this is I mu or H, or this is B or flux. This is positive Hm and this is minus negative Hm. Now this value of current which required from 0 to x to bring the flux from y to 0. If you give a current from 0 to m, the flux will come from y to 0. So this 0 to m is called force due to residual flux. You are applying additional force to reduce the residual flux to 0. Now coercive force is wasted to bring the negative flux to 0 to m, and only force m to z is useful. Yes, only this force is useful. 0 to m you have given to bring the force y to 0 and m to z. See, this is m to z. This m to z, this m and this z only use to magnetize core in second half cycle. In first half cycle, after having some 0 to x flux, you have given 0 to m I mu current to reduce the flux to 0. Now only m to z current is used to magnetize the core in second half cycle. This is called losses due to coercivity. And since here, losses due to hysteresis losses, one point you note here that as I have discussed earlier, for non-magnetic material like air, hysteresis loss is 0. That is, hysteresis losses present only in two types of material. I discussed this clearly when I discussed with you about magnetic materials. That is only in ferro and ferrimagnetic material, not in dia, para and ferrimagnetic anti-ferrimagnetic material. In case of air, the hysteresis losses is 0. This is the reason why the dynamometer type wattmeter air core coil is used to reduce the losses. Now you see, this is H or proportional to I mu, this is B. The area, if you know area, how you find area, you have read in 10+2 standard, y into x. If you do the product, you will get the area. If you do B into H, you will read in EMF that B into H will give area, that is energy loss. This is a curve. Since you are giving additional power loss, when you do B into A, it will give a form of losses. Now see, I have told you that all paramagnetic material, if you increase the temperature, will become diamagnetic material. Similarly, all ferromagnetic material, if you increase the temperature, it become paramagnetic material. Not dia, it become paramagnetic material. That is, paramagnetic material means here, if you increase the temperature, the curve become linear. That is, there is, I have told you, only hysteresis losses are present in ferro and ferri materials. So if interview were asked in any examination, if temperature of ferromagnetic material, or he may ask like this, if temperature of transformer core is increased, what will happen? One of the answer is hysteresis losses going to reduce, because the curve, the material become from ferromagnetic material to paramagnetic material, and in paramagnetic material hysteresis loss is 0. So this curve tends to linear. So one point you must note here that, this curve has more losses compared to this curve. Means a small curve means as the area going to reduce, the energy losses also reduce. See here, B into H, I told you, when you multiply X into Y, it will give area. B into H, you might have read in EMF, it is representing an energy loss. So as I have already told you in previous classes, see, all my previous classes are very important and all these are interlinked, because I interlink power system measurement, all power electronics, and made these notes. I took 1 month to make these notes very clearly. Now you must see here that in EMF you might have read about zeta susceptibility. What is zeta? Zeta is B by H. So if an examiner asks what is the ratio of y axis by x axis or B by H, what is the ratio of B by H in hysteresis loop, then what is the answer? It is zeta. Slope is given by zeta. Zeta depends upon property of material. You know also mu r equal to 1 plus zeta. I have discussed this clearly. One more point you note here, that in superconductors, all superconductors are diamagnetic material, and the value of mu r for diamagnetic material is 0, and the value of zeta is negative for diamagnetic material, and the value is similarly 0 for superconductors. All superconductors are pure diamagnetic material. If you take a gold, ladies will know about this much very much. If you take a gold and go to a gold maker, and if you ask is this gold pure, what he will do, he will melt it, since gold is a paramagnetic material, and they will keep in a container, test with some magnetic material. If it is a pure magnetic material, then that the gold which is in melted form tries to move away from that magnetic field, because since I told you diamagnetic material magnetize in opposite direction to the magnetic field, it tends to move away, so that by that effect a gold maker will know whether it is a pure gold or not. These all properties are interlinked. When you read EMF, read this carefully about zeta property. These are very important. Zeta will tell which is dia, which is para, and know the significance of EMF in very great detail. Since time is less, I am not discussing much more. Since there are so much to discuss there, let us move ahead as per restricted time. Now, hope you have understand that what is the consequences if it is you increase the temperature, and what is the area, and what is the slope. Now, if you feel at least 1% advantage, give me a thumbs up. It will motivate me. Now, hysteresis losses per 1 cycle equal to area enclosed. Yes, I have told you in area enclosed, hysteresis for F cycle means if 100 times hysteresis loop is formed, it is area enclosed into F time. Yes, if it is frequency is 50 Hz, it will enclose this area 50 times. That is the meaning, simply I have told. Hope you have understood, nothing to worry. Now, this is a Steinmetz formula which you must be remembered, since this is derivation. I think so you must know about empirical formula. What do you mean by empirical formula? A formula that does not have proof. Scientists, what they will do? They will conduct n number of experiment, and from that basis they will come to a conclusion. This is also similar for this empirical formula. You know the empirical formula in transmission line, that 5.5, see here, 5.5 root of 0.6 L plus P by 150 equal to V. Suppose now in generating station, suppose this equation, what does it means? In generating station, they are generating level kV. Now to reduce losses, they will step up the voltage. Now how much they are going to step up? 132 kV, 220 kV, 465 kV, 800 kV. Now how they will decide? They will decide based upon length, based on power. And if they substitute here, I will they get a rough voltage, and by that they are going to step up. So this is also empirical formula. Empirical formula means which does not have proof. Scientists do n number of experiment and they will get a conclusion. Similarly here, this formula is, you must remember as it is. See here, WH hysteresis losses is neta is a coefficient. Now next is Bmax power x. Bmax here representing peak value of flux density. You must remember here that phi which is used here is Pmax, whereas the phi used in induction machine and synchronous machines are RMS value. This point you must not observe keenly when you are reading in a machine just as everything as a B, but the Bmax, the B which is used in transformer is a peak value. Now F is frequency, V is not voltage, V is volume. Don't confuse here with voltage. V is volume. See, I have told you, if you increase I mu, B will increase up to some time, then it is going to saturate. So height of this BH curve is determined by the magnetizing current, whereas this area is depend upon volume of conductor. Similarly, it is proportional to volume now. If you increase the volume, the area of conductor also increases, whereas if you decrease the volume, area of conductor decreases. Sorry, area of hysteresis losses decreases. Height is determined by Bmax, that is due to saturation, whereas this area of BH curve is determined by the volume of the core. Hope you must read this very keenly and carefully, how each term used here, how they are going to interlink. Now let us take, suppose once a transformer has been designed and given to manufacturer. Now neta is coefficient constant, Bmax he can vary. How Bmax is vary? Bmax is proportional to V by F. Where I got this equation? I got from EMF equation of transformer. Frequency you can vary by cycloconverter, by inverter, by anything you can vary the frequency. Volume of transformer core is constant. So the what you can say, customer can have only Bmax and F to vary. Now let us see how Bmax and F is varied and how the hysteresis loss going to increase or decrease here. See here, once again I am telling, this Tiefing coefficient varies between 1.5 to 2.5, where it is 1.6 for silicon steel, so that it is having, since it is proportional to B power X, if X value is less, hysteresis losses is less, so that we use silicon steel rather than using any other steel like cast iron, cast steel. I have told you now, I have shown the graph there where the highest value is for silicon steel, so that hysteresis losses reduces. It depend upon the property of material. X is depend, this X is depend upon material, this X is depend upon material, so it is also playing a major role. Bmax, saturation determine the height, volume of the core determine the width, and this X determine the type of material and how much loss is interlinked. Now let us see how the variation of voltage and frequency affect the hysteresis losses. See this point again, height is determined by Bmax, I have told you how. Width is determined by the volume of transformer core. I discussed already these 2 points. I took these points from so many different coaching notes, textbooks, standard textbooks, NPTEL videos. I referred so much and made these notes. It take me great efforts, and we are providing you for free. If you like, please hit a like button. It is free of cost. Now see variation of operating parameters. Bmax is proportional to V by F. You know, if V by F is constant, that is, we are making Bmax of the transformer constant. Now if Bmax is constant, it depends only on frequency. So suppose, as I have told you, if you increase frequency, hysteresis losses increases. See this case, when Bmax increases, when Bmax constant and frequency is increased, hysteresis losses increased. You accept it. Now take a case where V by F is not constant, that is Bmax is not constant. Hysteresis loss then V power X by F power X into F. Now you separate it, you will get hysteresis losses proportional to V power X by F power 1 minus X. Suppose it is a silicon steel, normally we use, if then substitute X equal to 1.6, it's become V power 1 by 6 by